Alright, hey there folks, and welcome back to chemistry. Right before we left school, we were asking the question, what's the concentration of vitamin C in the school's juice? And a lot of you on that day were nice enough to actually donate your juice from lunch, and I have it right here. I took it home with me. And this week, we're going to go ahead and proceed with that experiment. Let's take a look at the juice. Alright, now I'll bet, just by looking at this juice, you couldn't tell me how much vitamin C is in there. I mean, you can see the juice, but you can't see the vitamin C chemical. That's where this comes in. Iodine indicator. Indicators in chemistry change color when they're exposed to certain chemicals, allowing us to see chemicals such as vitamin C that we normally would not be able to. And that's going to be really key to answering that question of how much vitamin C is in these juice boxes. Take a look. So I'm going to start by making my vitamin C solution. There you see I have 2 grams of vitamin C powder going in there. And I'm going to put 500 milliliters of water, which is half a liter. So if you do the math, the concentration per liter is 4 grams. 4 grams per liter in my original solution of vitamin C that I'm going to use in my experiment. So our question is, what is the concentration of vitamin C in the school's juice? And we're going to use iodine to figure that out, I2. And I2 can be in one of two forms. It's either going to be bonded together like you see on the left there, or it's going to be split into its individual ions like you see on the right. And when it's bonded, it's brown, like as you can see in the flask, and when it's not, it's clear. And the thing that can make it change from having that covalent bond to being ions is vitamin C itself. So there you see I have a test tube of vitamin C, and I'm dropping that iodine in, and it's turning clear. You can put a lot of iodine in there. It'll just keep turning clear. In comparison, if I put the iodine in water, water is not going to break that covalent bond, and the iodine is going to stay brown. Now, at a certain point, if I add a ton of iodine into that vitamin C, it's going to reach a point where all the vitamin C gets used up, and once that happens, it can't break the bond on iodine anymore, and iodine stays brown. So because of this, you can use iodine to figure out how much vitamin C is in something. But first, you have to figure out what that relationship is between the concentration of vitamin C and the amount of iodine that you're putting in. So in the experiment for this week, we're not going to be answering the question about the juice yet. We're going to be trying to figure out what's the relationship between that concentration of vitamin C and the amount of iodine you can put in before it turns brown. So I'm going to set up 5 trials with different concentrations of vitamin C. In that first trial, I'm going to do all vitamin C, 20 drops of vitamin C, 0 drops of water. And then in the second one, I'm going to go with 15 drops of vitamin C and 5 drops of water. So 3/4 vitamin C, 1/4 water. In the third one, I'm going to do half and half, 10 drops vitamin C, 10 drops water. In the fourth one, I'm going to do 5 drops of vitamin C, 15 drops of water. That's 1/4 vitamin C. And then in the last one, I'm not going to put any vitamin C. It's just going to be all water. So now for the concentration. The original trial, the original solution I made, has 4 grams of vitamin C powder per liter. That's the concentration. So in trial 2, where suddenly it's 3/4 vitamin C, 1/4 water, it's going to have 3/4 of that initial concentration, which is 3 grams per liter. In my third trial, I went half and half. vitamin C in water. So it's going to have half its original concentration. So instead of 4, it's going to be 2 grams per liter for trial number 3. And then for trial number 4, it's a quarter of the original vitamin C. So that means our concentration is going to be 1 gram per liter. And in trial 5, I don't have any vitamin C at all. So our concentration is 0 grams per liter. So at this point, what I'm going to do is make those solutions, first adding drops of vitamin C, and then adding drops of water. And now for each trial, we're going to see how many drops of iodine it can take before it turns brown. So our first trial here, we've already put 3 in. There's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and you see there, oop, it turned brown. Okay, so our first trial, our 4 gram per liter concentration trial took 13 drops. We'll do that for the rest of the trials. Snowball, get out of the way. I'm trying to make a video here. So at this point, we have enough data to figure out the relationship between the concentration of vitamin C and the number of drops of iodine that we have to put in. Next week, we'll actually do an experiment with the juice to figure out its concentration. Make sure, if you haven't yet, to watch my announcement video, which is going to be the first thing you see when you log on to my Google Classroom. On there, I'm going to talk about expectations as we move forward with our distance learning. I hope you're all doing well, and have a nice week.